Hello guys, in this video I'm going to show you how to make a blink using the FreeRTOS for the Milky V Duo. So first we're going to go to the website of the Milky V Duo. It's in this. So we're going to scroll down and we're going to need some documentation. We're going to need the datasheet for the CV1800 and also the datasheet for the tool on board. And then we go to docs, then tool. We're going to scroll down. I'm going to open image download and how to build image. So image download. We're going to the latest release and download the source code. One of these two. Then in and how to build, there will be the instructions to build the source code. Main ones are these, so you have to install these packages. So you have to extract the source code, and we'll also open the Milky V datasheet. So we're going to the table of contents and then to LEDs. This we have here the description of the built-in LED. So it says here that the blue LED is connected to GPIO C 24 pin of the CV1800 microcontroller and can be controlled by the user software. So we're going to configure this GPIO. So we have to open the datasheet for the CV1800, where we will scroll down to the table of contents and find here GPIO. So we will have here on peripheral equipment, we have GPIO page 536. So 536. And here we have the GPIO section. On the same page, we have the instructions, the steps on how to configure the GPIO as input or output. So first we have to configure the SW port A DDR register and set it as input or output. And then we will have to, if it is configured as input, we'll have to configure this export A to read this register in order to check the value of the input signal. And if it is configured as output, we'll have to set the respective bit on this SW port A DR register to set the output of the GPIO pin. We have here the base registers. On the data sheet of the Duo, it says here that it is GPIO C, but there is no GPIO C here. So we have to interpret that as A as 0, B as 1 and 2, and C as 2. So our GPIO 2 here will be the C on the Milky V datasheet. Okay, and then we have here the registers. So let's go hands-on. So you extracted already dual source code. So we'll open this directory. We will go to FreeRTOS, civtech, task, com, source, risk v64, and we have here 3 files. This still here are some definitions and functions to set the GPIO output. We won't use them, but it's already implemented here. If you want to use them. So what are we going to do here? We'll first delete this file. These two, Milky V to Dual IO. We won't use them. So we'll open this com main.c. We will remove this Milky V, this line 22 that says include Milky V Dual IO. We will delete this, or else we can comment it out, and then we can delete all of this. Delete and also delete everything down of main. Also delete this and this. So what are we going to do? Up here before main, we will create our task. So it is, we call it void. What about blink? Let's call it blink void and param. This param here, it will be received from the FreeRTOS, but we won't use it. So what do we do here? Do you remember the steps? First we have to configure the SW port A DDR for the GPIO 2. So what are we going to do? We have a pointer now, so it is a pointer for the needs, and the address is um, 0x OCO22000 plus the offset. What is the offset? The DDR is 0x4004. Okay. And this here we will turn on the pin and bit 24. So we're going to do this. Okay. And then we will start our infinite loop, and then we will also do this int 0302200 plus the, and then we have to set the GR register. So, and its offset is 000. We don't need to sum 0 here, but for better comprehension, better understanding, sorry, we'll do this here. And then we'll set bit 24. We're going to need a delay here, and then we'll have to turn off that bit. So let's first turn off the bit. So pointer, we can copy this line, but here we're not going to use no, sorry, we're going to use an AND operation, and then we're going to turn off only that bit. Okay, and the delay, I never remember the delay syntax, so I'm going to look here. It's vtask delay, and then we're going to use this. We have to pass the number of 6, so vtask delay the number of bits. So if I want 500 milliseconds, I'm going to divide it by the port period. Okay, I'm going to put it here, and then we're going to use 200 here, so that we can see the difference between the two of them. And then to create the task, I'm going to copy and put it here because I never remember this. So blink is the name of this function. We give it a name for the task, stack size, and also parameters, and we start the scheduler. Okay, that's it. We can save this, and then we're going to the root of the build root. So we're gonna open a terminal here, and what do we do here? We run build.asset, and then we can put also here build launch, and then we can choose the port or the target. As I have here a Milk V2, I'm going to choose one. The first time you run this, it will download the host packages, and then it will compile the source code. I have already compiled this, and then when you compile, there will be an output directory, out here. So you open this here, this directory, and it will have your image. I have already it here, and then you're going to insert your SD card, and you can use Balena Etcher to burn your SD card. So I'm gonna open it here. So go to fresh file. So you choose your image, and then you choose your SD card and click on flash. Okay, I won't do that here because it is already burned. But you have one more step to do. You go to rootfs on your SD card, and then you go to mnt system, and you will have here build.asset. This is the script that is responsible for the blinking of your LED on the first core, but you don't want it running, so you can delete or rename this script. So I'm going to rename to blink.asset underscore backup, and then it's all ready. You can eject your SD card and then insert it in your Milk V2. So I'm gonna insert it here. Connect the USB, and when you connect, it will start blinking. And that's it. Later I'm going to show you, in the next video I'm going to show you how to make a better C code for this. uh, so that's it.